everyone, welcome to Integrals Derived. My name is Sanjana and I'll be talking about math and medicine today. So math and medicine. You wouldn't really think that these two fields of STEM are related, right? But what if I told you they are? Math and medicine are two very distinct and different fields, but are related. And as we all know, math is used everywhere in every single scenario all around the world. But this video will go specifically into how math is used in medicine. So how could possibly math be used in medicine? We all know that math is related to mathematics and medicine is related to science, and we need to know how are they related. Instead of me telling you how they're related, let's figure it out together. Let's say you have to pick up some medicine from a physician because they prescribed it for you. Well, some questions that you may consider are, how much of the medicine should you have? How much of the medicine per dose? And for how much time you should take the medicine? And how should you take the medicine? So how do doctors figure out all these questions? They do it using math. Physicians use math to calculate the dosage of certain medicines to prescribe, and variables such as the patient's mass, previous conditions, and unit conversions are considered when prescribing amounts of medicine. So now let's look at the three ways doctors calculate medication dosages. There are three methods. There is the desired over have or formula method, there's a ratio and proportions method, and there's the dimensional analysis method. Our first method is the desired over have formula method. This method is useful for checking the accuracy of other methods of calculation, which will be discussed later. So this is kind of the backup, the triple check, as they say, to make sure that their prescriptions are correct. The formula for this is D over H times Q equals X, where D is the ordered dose amount, H is the amount on hand, Q is the quantity, and X is the desired dosage amount. This is also used to find the volume dose of liquid medicine. So now let's look at a sample problem together. Example, a patient requires 200 milligrams of Benadryl. The amount available is 100 milligrams per milliliter. So it's 100 milligrams and 1 ml of oral solution. What is the desired dosage? So our first step is to identify the variables, D, H, Q, and X. So as seen in the formula, let's take 2 seconds to determine what each of the variables are. The variables are D is 200 milligrams, H is 100 milligrams, Q is 1 ml, and X is what we need to find. Now let's solve using the formula. So we just plug in all of the numbers into the formula and find that the answer is 2 ml of Benadryl. Now you try a problem. A patient requires 30 milligrams of dihydrocodone. The available amount is 10 milligrams per 5 milliliters oral solution. What is the desired amount? We will go over the answer to this at the end of the presentation. The second way that medicine is calculated is through the ratio and proportions method. This method has been used for several decades because it is very simple, only involving multiplication and division. The formula for this is just how you would solve a proportions equation, where H over Q is equal to D over X, where, as we said in the first method, the same variables remain as the same definitions. So now let's look at another example. A provider needs 4 milligrams of lorazepam. There are 2 milligrams per milliliter vials on hand. So how many milliliters are needed to carry out the ordered amount? So as we did before, let's identify the variables. D, H, Q, and X. Where D is 4 milligrams, H is 2 milligrams, Q is 1 milliliter, and X is what we need to find. Now, just like we did before, we're going to solve using the formula. So using the formula, we can see that 2 milligrams over 2 milliliters is equal to 4 milligrams over X, and X is equal to 2 milliliters. Now you try another example. A physician requires 5 milligrams of morphine. There are 3 mg over ml vials on hand. So how many milliliters are needed to carry out the ordered amount? We will again go over this at the end. Now, the very last method is dimensional analysis. If you have taken a high school chemistry class, then you must know what dimensional analysis is. If not, don't worry. You're going to learn about it right now. Dimensional analysis is finding relationships between different quantities and the units of measurement through calculations. For example, you would use dimensional analysis to find the relationship between gallons and liters, or between feet per minute and miles per hour. In our medicine example, the relationship would be between the amount of medicine present and the amount desired. There is no formula because the analysis is being done across different units. Example, a provider needs 4 milligrams of lorazepam. There are 2 mg over ml vials on hand. So how many mLs are needed to carry out the ordered amount? First, let's set up the dimensional analysis method. So as you can see here, X is equal to 4 mg over 1 and 1 times 1 ml over 2. And if we solve this, this would be equal to 2 ml. And I will now go over how this works. How does this method work? So you multiply something across and divide if something is below. So as we saw in the previous example, we multiplied 4 times 1 and then divided that by 2. This is called dimensional analysis because we calculated over different dimensions, milligrams and milliliters. So we need to eliminate different units. When dividing the 4 mg and the 2 mg, we eliminate the mg, so we end up with milliliters. So why is all of this important? Why is math and medicine important? Think about this for 2 seconds and we will go over this. Finding the amount of a certain medicine that a certain person needs in real time could possibly save someone's life. Also, a miscalculation in the amount of medicine could possibly result in detrimental effects. So it's important that these math calculations be done in order to prescribe medicine safely and correctly. So it's important to calculate the correct amount of certain medicine because if you take too much, it could be harmful for you, and if you take too less, it may not be effective. So the answer to our practice problems, so the first one is 15 ml and the second one is 5/3 ml. Alright, thank you guys for watching this really long math video. I hope you guys learned something. So keep learning math and have an amazing time at SciFest.